Why do we age and how can we stop aging? If you manage to watch this short documentary until the end, you will learn this great secret that modern science holds. Aging is a natural process experienced by all living beings. However, it is not simply the passage of time reflected in our appearance or how we feel. Biologically, aging is a complex phenomenon that affects every cell, tissue, and organ in our body, deteriorating their function over time. For decades, scientists have tried to understand the causes of aging. Today we know that it is not a single factor, but a series of interconnected processes that occur inside our cells. These processes are so fundamental that they are known as the hallmarks of aging, and they help us understand why we age and what we can do to slow down this process. One of the most important discoveries in this field is that aging is not something completely beyond our control. Although we cannot stop it, recent research has shown that it is possible to influence how we age. This does not mean seeking immortality, but rather extending the years of healthy life, during which we can enjoy our daily activities without the limitations brought by diseases or physical deterioration. When we talk about the markers of aging, we refer to key elements like the stability of our DNA, the functioning of our mitochondria, which are like small energy factories inside our cells, or the ability of our cells to repair themselves. Each of these markers represents an area that science is exploring to understand how to prolong not only life, but quality of life. It is important to note that this knowledge does not stay in the laboratory. Research advancements in aging are beginning to translate into practical solutions that could transform how we live our later years. From genetic therapies to interventions improving cell function, we're closer than ever to having tools to age better. Understanding aging is not only about science, but about how it empowers us to make more informed decisions about our health and well-being. Each discovery in this field brings us closer to a life where the years are not only added to the calendar, but also to our vitality and ability to enjoy the present. This video is the beginning of a journey through the foundations of what we know about aging. We will talk about the markers that determine how we age, the scientific advances that promise to change the way we face this process, and most importantly, how we can take control over the quality of our life as time passes. So grab a pen and pay close attention. The essence of aging. Simply put, aging is an accumulation of damage that the body cannot completely repair. This damage affects everything from the DNA within our cells to the mechanisms that regulate energy production and eliminate cellular waste. Think of aging as a building that, over the years, accumulates cracks and wear in its structure. While the building can remain standing for a while, without adequate maintenance, those cracks will eventually cause more serious problems. In recent years, scientists have identified 14 main characteristics that define aging at the cellular level, known as the hallmarks of aging. Each of these markers describes a specific aspect of cellular deterioration, from mutations in our DNA to the loss of communication between cells. The interesting thing is that, although each marker has its own characteristics, they are all connected, like pieces of a puzzle that together explain why we age. What makes this field of study exciting is that these markers are not merely passive observations, they are potential targets for scientific interventions. If we manage to influence them, we could not only slow down aging, but also prevent or delay many of the diseases associated with age, the 14 markers of aging. To understand why we age, science has identified 14 fundamental aspects known as the hallmarks of aging. Each of them describes a biological process that contributes to the deterioration of our cells and ultimately, our body. These hallmarks do not function in isolation. They are interconnected, and together they explain the changes we experience over time. Let's briefly explore them before diving deeper into them in the next sections. Number 1. Genomic instability. The foundation of aging. DNA is the core of all genetic information that makes life possible. Every cell in our body contains a complete set of this genetic material, which acts like an instruction manual for all biological functions. However, this manual is not immune to damage. Throughout life, our DNA faces constant assaults both internally and externally. This phenomenon, known as genomic instability, is one of the main markers of aging. What causes genomic instability? DNA can be damaged by a variety of factors. Some are external, such as exposure to ultraviolet radiation, pollution, toxic chemicals, and smoking. Others are internal, like free radicals generated during cellular metabolism and errors that occur during DNA replication. As we age, our ability to repair this damage decreases. Cells have specialized mechanisms to identify and correct errors in DNA, but over time, these systems lose efficiency. This results in the accumulation of mutations and genetic alterations that can disrupt the normal functions of cells, the consequences of genomic instability. When the DNA of a cell is damaged, one of three things can happen. 1. The cell successfully repairs the damage. This is ideal and happens more often in youth when the repair systems are at their best. 2. The cell becomes senescent. This means it stops dividing but remains alive. Although this response prevents damaged cells from becoming cancerous, their accumulation can contribute to inflammation and tissue deterioration. 3. The cell dies or transforms into a cancerous one. In extreme cases, irreparable damage can lead to apoptosis, programmed cell death, or tumor formation. The accumulation of genetic damage not only accelerates aging, but it is also directly related to serious illnesses such as cancer, neurodegenerative disorders such as Alzheimer's and cardiovascular diseases, scientific advances against genomic instability. Research on genomic instability has led to the development of promising therapies. For example, scientists are exploring ways to enhance natural DNA repair systems. One strategy includes the use of small molecules and peptides, such as ARAA290, which have shown potential to reduce genetic damage and improve genomic stability in preclinical studies. Another area of research focuses on the use of CRISPR gene editing technology, which allows for the correction of specific mutations in DNA. Although this technology is in its early stages, it represents an exciting possibility for treating diseases related to genomic instability. What can we do today? Although we cannot completely eliminate DNA damage, there are practical steps that can help reduce its impact. Protecting yourself from external damage, using sunscreen, avoiding smoking, and minimizing exposure to environmental pollutants can reduce the factors that damage DNA. Maintain a diet rich in antioxidants. Antioxidants, present in foods like fruits and vegetables, help neutralize free radicals that damage DNA. If you want a video about the complete list of foods with the highest amount of antioxidants, let me know in the comments section. Adopting a healthy lifestyle, regular exercise, adequate sleep, and stress reduction support. DNA repair mechanisms, genomic instability is undoubtedly a fundamental challenge in aging. However, thanks to scientific advances, we are getting closer to understanding how to protect and repair our DNA, which could pave the way for a longer and healthier life. In the next section, we will explore another key marker of aging, the shortening of telomeres and their role as the biological clock of our cells. Shortening of telomeres. The biological clock of cells. At each end of our chromosomes, there are structures called telomeres. These small sequences of non-coding DNA act as protectors, ensuring that the essential genetic information remains intact during cell division. However, telomeres are not eternal. With each cell division, they progressively shorten, and when they reach a critical length, the cells lose the ability to divide. This phenomenon, known as telomere shortening, is another key marker of aging. What are telomeres, and why are they important? Telomeres function like the plastic tips that protect the ends of a shoelace, preventing it from fraying. In this case, they protect the DNA of the chromosomes so that it does not degrade or fuse with other chromosomes. Without these shields, the genetic material would become unstable, resulting in catastrophic errors in cellular function. With each cell division, telomeres lose a small portion of their length due to a limitation in the DNA replication process, known as the end replication problem. When telomeres become too short, cells enter a state of replicative senescence or die, which contributes to tissue aging, telomere shortening, and aging. Telomere shortening is not only related to cellular aging, but also to a series of age-related diseases. Studies have shown that people with shorter telomeres are at higher risk of developing cardiovascular diseases, type 2 diabetes, neurodegenerative diseases, and some types of cancer. Additionally, factors such as chronic stress, inflammation, and unhealthy lifestyles can accelerate telomere shortening, increasing the risk of premature aging and related diseases. Can we slow down telomere shortening? One of the most promising areas in aging research focuses on the enzyme telomerase. This enzyme has the unique ability to lengthen telomeres by adding repetitive DNA sequences to their ends. However, telomerase activity is low or non-existent in most human cells after birth. Some scientific interventions aim to reactivate telomerase in a controlled manner to extend the lifespan of cells. For example, the peptide epitolon has shown in preliminary studies the ability to stimulate telomerase production, lengthening telomeres and improving cellular longevity in model organisms. What can we do in daily life? Although therapies based on telomerase are still in development, there are practical measures that can help protect our telomeres and delay their shortening. 1. Reduce stress. Chronic stress is associated with accelerated shortening of telomeres. Techniques like meditation, yoga, or deep breathing can help mitigate its effects. 2. Adopt a balanced diet. Consuming foods rich in antioxidants like fruits and vegetables can protect telomeres by reducing oxidative damage. 3. Maintain an active lifestyle. Regular exercise not only benefits the heart and muscles, but is also linked to greater protection of telomeres. 4. Avoid harmful habits. Smoking and excessive alcohol consumption are linked to accelerated shortening of telomeres, so eliminating or reducing them can be beneficial. The future of telomere research. In the next section, we will explore another critical marker, epigenetic alterations, which act as the switches that turn genes on or off in our cells. This mechanism profoundly influences how we age and the diseases we face throughout life. Epigenetic changes, the silent driver of aging. Our genes contain the information that defines how our body functions, but they don't work alone. Epigenetics refers to the mechanisms that regulate which genes are turned on or off at any given time, without altering the underlying DNA sequence. Think of epigenetics as the conductor of an orchestra. It does not create the music, the genes, but it decides when and how each instrument should play. As we age, this control system begins to fail, leading to disorders in gene expression and contributing to aging. In the next section, we will address another fundamental marker of aging, the loss of proteostasis, the delicate balance that regulates proteins in our cells and how its disruption contributes to the deterioration of the organism. Loss of proteostasis, the balance of proteins. Proteins are the building blocks and workers of our cells. From transporting nutrients to repairing tissues, they play an essential role in almost all biological processes. However, like any complex system, proteins require a precise balance to function correctly. This balance, known as proteostasis, involves the production, folding, removal, and recycling of proteins in our cells, which is the loss of proteostasis. Over time, factors such as oxidative stress, genetic mutations, and general aging make it difficult for our cells to maintain this balance. This leads to the accumulation of misfolded or damaged proteins that cannot be efficiently eliminated. These defective proteins tend to form aggregates that interfere with normal cellular functions, contributing to neurodegenerative diseases like Alzheimer's and Parkinson's, as well as metabolic problems and chronic inflammation. How does it affect aging? The loss of proteostasis is not just a symptom of aging, but also one of its causes. As cells accumulate damaged proteins, the systems responsible for eliminating them, like the proteasome and autophagy, become less efficient. This creates a negative cycle. The accumulated damage overwhelms the cellular cleaning systems, which leads to a greater accumulation of waste and eventually to cellular and tissue deterioration. Scientific advances in proteostasis. Research in this field is exploring ways to restore protein balance and improve cellular health. A promising example is the peptide GHK-Cu, which has been shown to promote proper protein folding and improve cellular function in preclinical studies. This type of intervention could help mitigate the negative effects of the loss of proteostasis and delay aging. Another interesting approach is the development of drugs called molecular chaperones that assist in the correct folding of proteins, preventing them from accumulating harmfully. How to protect proteostasis in daily life. You have seen that I recommend regular exercise in each of the previous sections. This is not a coincidence. Exercise is possibly the #1 factor for a long and good life after nutrition. However, you shouldn't overdo it, as too much exercise is also bad. If you're interested in a video about the topic, you know what to do. Nutrient sensor deregulation, the energy imbalance. In our body, there are systems that detect and respond to the available nutrients. These systems act as sensors that adjust our metabolic functions depending on what we eat. However, over time, these sensors can become less accurate, a phenomenon known as nutrient sensor deregulation that affects our ability to maintain a healthy metabolism. How do nutrient sensors work? Among the key nutrient sensors are 1. The mammalian target of rapamycin pathway activates cell growth processes and protein synthesis when nutrients are abundant. AMPK, AMP-activated protein kinase, senses low energy levels and activates mechanisms to conserve resources. 3. Sirtuins, metabolic regulators related to cell repair and longevity. When these sensors are well synchronized, the body can efficiently adapt to changes in nutrient availability. However, with aging, this coordination deteriorates, contributing to metabolic imbalances that favor diseases such as obesity, type 2 diabetes, and cancer. The impact on aging. The deregulation of these sensors directly affects the way our body responds to food consumption. For example, the hyperactivation of the mTOR pathway, common in high-calorie diets, accelerates cellular aging by promoting inflammatory processes and the development of chronic diseases. On the other hand, interventions such as calorie restriction have been shown to extend lifespan in animal studies. This approach works by modulating these sensors to optimize metabolism and reduce the negative effects of dysregulation. New therapies and development researchers are exploring therapies that mimic the effects of caloric restriction without drastically reducing food intake. For example, tirzepatide and semaglutide. These peptides are being studied for their ability to restore the balance of nutrient sensors, improving insulin sensitivity, and regulating metabolism. How to maintain a healthy nutrient sensor. Although specific therapies are still in development, you can support your metabolic sensors with the following strategies. 1. Maintain a healthy weight. Obesity negatively affects the function of nutrient sensors. 2. Include intermittent fasting. This approach may improve the sensitivity of metabolic pathways and promote autophagy. 3. Reduce the consumption of sugar and ultra-processed foods. These deregulate metabolic pathways, especially insulin sensitivity. 4. Prioritize a balanced diet. Foods rich in fiber, healthy fats, and lean proteins help maintain a stable metabolism. The deregulation of the nutrient sensor not only affects how we use energy, but also how long and with what quality we can live. In the next section, we will explore a critical aspect of aging, mitochondrial dysfunction, the deterioration of the power plants of our cells. Mitochondrial dysfunction, the decline of the power plants. Mitochondria, known as the powerhouses of our cells, are responsible for producing the fuel that sustains our vital functions. Without them, our cells would not have the energy needed to survive. However, over time, these organelles lose efficiency and functionality, which is known as mitochondrial dysfunction, a key marker of aging. How does mitochondrial dysfunction affect aging? As mitochondria age, their ability to produce energy in the form of adenosine triphosphate decreases. Additionally, they generate more reactive oxygen species, commonly known as ROS, harmful molecules that attack DNA, proteins, and cellular lipids. Mitochondrial dysfunction also alters key processes like calcium regulation, essential for cellular signaling, and can trigger apoptosis, programmed cell death, which affects tissue regeneration and repair. New therapies to revitalize the mitochondria. Current research aims to improve mitochondrial function through specific therapies. Among the most promising are peptides like SS31 and humanin. These compounds have shown in preliminary studies the ability to reduce oxidative stress, improve mitochondrial efficiency, and restore energy production. Supplements like coenzyme Q10 and NAD+, both support mitochondrial energy production and reduce oxidative damage. Cellular senescence, when cells stop dividing. Cellular senescence is a state where cells lose their ability to divide, but do not die. Although initially, it is a protective mechanism designed to prevent the proliferation of damaged or potentially cancerous cells, its accumulation over time can have negative effects on tissues and organs. What causes cellular senescence? Various factors can trigger cellular senescence, including DNA damage, oxidative stress, telomere shortening, and chronic inflammation. Once the cells enter this state, they start releasing inflammatory molecules, known as the senescence-associated secretory phenotype, SASP, which damage the cellular environment and contribute to tissue aging. Consequences of cellular senescence. Although senescence is initially protective, its accumulation with age can contribute to a series of problems, like chronic inflammation, immune system dysfunction, and aging-related diseases, including fibrosis, atherosclerosis, and cancer. Scientific advances against cellular senescence. One of the most promising areas of research is senolytics, compounds designed to eliminate senescent cells. For example, the FOXO4-DRI peptide has shown potential to selectively destroy these cells, reducing inflammation and improving tissue function in animal models. Stem cell depletion, the decline of regeneration. Stem cells are the regenerative reserves of the body. They have the ability to divide and differentiate into different types of cells, making them essential for tissue repair and renewal. However, with age, these cells lose their ability to self-renew and their functionality, a process known as stem cell exhaustion. What causes stem cell exhaustion? Aging affects both stem cells and their microenvironment, known as the niche. When stem cells lose their functionality, the body's ability to repair tissues decreases, resulting in general deterioration and increased vulnerability to diseases. The impact of stem cell depletion on health. This process is related to issues such as loss of muscle mass, sarcopenia, the decrease in bone density, osteoporosis, and skin deterioration. It is also associated with diseases like anemia and heart failure, where tissues cannot regenerate efficiently. Intercellular communication altered. The silence of the cells. In a healthy organism, cells are in constant communication, sending and receiving chemical signals that coordinate essential functions, such as growth, repair, and immune response. However, as we age, this communication becomes less efficient, which is known as altered intercellular communication. This deterioration negatively affects the tissue's ability to sustain and repair themselves, contributing to aging and related diseases. How is cellular communication altered? As we age, cells start sending conflicting or harmful signals. For example, senescent cells. These cells secrete inflammatory molecules that interfere with normal communication. Chronic inflammation. Persistent inflammation alters the chemical signals, promoting tissue damage and aging. Deterioration of the immune system. Immune cells lose efficiency, making it difficult to eliminate damaged cells and pathogens. Impact on aging. The alteration of intercellular communication is related to a wide range of problems, from chronic inflammation and autoimmune diseases to the body's inability to repair wounds or fight infections. This process also contributes to the development of diseases such as arthritis, type 2 diabetes, and pulmonary fibrosis. Scientific advances in restoring cellular communication. Recent research is exploring ways to re-establish cellular communication. For example, interventions with peptides. Peptides like TB500 have shown potential to modulate intercellular signals, enhancing tissue regeneration and reducing inflammation. Use of exosomes. These small vesicles carry chemical signals between cells and are being studied as a tool to restore damaged communication. Compromised autophagy. The cleaning system that fails autophagy is an essential cleaning process in which cells break down and recycle damaged or unnecessary components. This mechanism ensures that cells function optimally, eliminating accumulated waste. However, with aging, autophagy becomes less efficient, resulting in an accumulation of cellular waste and general deterioration. What is autophagy, and why is it important? Autophagy functions as an internal recycling system. When cells detect damaged components, such as misfolded proteins, defective mitochondria are encapsulated in structures called autophagosomes, which then fuse with lysosomes to break down and recycle materials. This process not only removes waste, but also provides energy and components to repair cells. The role of autophagy in aging. The reduction of autophagy negatively affects the ability of cells to adapt to stress and repair damage. This accelerates cellular aging and promotes chronic inflammation, two key factors in the overall deterioration of the body. How to naturally stimulate autophagy. 1. Practice intermittent fasting. Controlled fasting can activate autophagy by forcing cells to recycle internal resources, reduce calorie intake. Moderately restrictive diets can improve autophagy without negatively affecting health. Dysregulation of RNA processing, lost control. RNA acts as an intermediary between DNA and proteins, translating genetic instructions into specific cellular functions. During aging, RNA processing becomes less efficient, a phenomenon known as RNA processing dysregulation, which interferes with the production of proteins essential for cell function. How is RNA processed? The RNA is generated in the cell nucleus as a copy of the DNA. Before being used, it goes through an editing process called splicing, in which non-coding sections are removed and coding sections are assembled to form a functional message. During aging, this process deteriorates, leading to errors in protein production. Impact on aging. The deregulation of RNA contributes to neurodegenerative diseases, muscle weakness, and loss of function in critical tissues. Additionally, it affects the cell's ability to respond to stress and repair damage. What speeds up aging? Scientific advances in RNA processing. The interest in improving this process has led to promising interventions like NAD+. This natural compound involved in energy metabolism also helps improve RNA function and reduce the effects of aging. Splicing factors. Initial studies suggest that it is possible to restore more youthful splicing patterns to improve cellular function. How to protect RNA processing. 1. Consume foods rich in niacin. This nutrient is a precursor of NEAT+, essential for cellular function. In the next section, we will explore how imbalances in the microbiome affect aging and what strategies exist to maintain a healthy and balanced gut flora. Microbiome imbalance. The impact of bacteria on aging. Our body hosts trillions of microorganisms, mainly in the gut, which form what we know as the microbiome. These bacteria play a crucial role in our digestion, metabolism, and immune system. However, over time, the balance of the microbiome can be altered, which is known as dysbiosis, a factor that contributes to aging and various diseases. What causes an imbalance in the microbiome? As we age, factors such as diet, stress, medication, especially antibiotics, and chronic diseases, affect the diversity and composition of gut bacteria. This leads to a decrease in beneficial bacteria and an increase in harmful microorganisms, which can trigger inflammation and tissue damage. The microbiome and aging. Microbiome imbalance is related to chronic inflammation. Dysbiosis can cause systemic inflammation, known as inflammaging, which affects organs and tissues. Deterioration of the intestinal barrier. An imbalanced microbiome can weaken the intestinal barrier, allowing toxins and pathogens to enter the bloodstream. Scientific advances to restore the microbiome. Research is developing strategies to rebalance the microbiome. Peptides like BPC-157. This compound helps repair the intestinal barrier and restore a healthy microbiome. Probiotic and prebiotic therapies. Probiotics provide beneficial bacteria, while prebiotics supply nutrients for these bacteria to thrive. Fecal microbiota transplants. Although still in the experimental phase, this technique has shown efficacy in restoring a healthy microbiome in some cases. How to take care of your microbiome. 1. Consuming foods rich in fiber helps feed beneficial bacteria. 2. Avoid the unnecessary use of antibiotics. These can eliminate beneficial bacteria along with the harmful ones. 3. Incorporate probiotics and prebiotics. Foods like yogurt, kefir, bananas, and asparagus are excellent options. Changes in mechanical properties. The stiffness of aging. As we age, both cells and tissues undergo changes in their mechanical properties. For example, tissues become more rigid, less elastic, and more prone to damage. This phenomenon affects key functions like movement, breathing, and blood circulation. What causes the changes in mechanical properties? Fibrosis. The accumulation of rigid collagen in tissues causes a loss of elasticity. Changes in the extracellular matrix. This network that supports the cells becomes less flexible. Alterations in the cytoskeleton. Cells lose the ability to change shape or move efficiently. Impact on aging. These changes are related to problems like high blood pressure. The stiffness of the arteries increases blood pressure. Loss of mobility. The stiffness of muscles and joints makes movement difficult. Respiratory problems. The stiffness of lung tissue reduces oxygenation capacity. Scientific advances in mechanical properties. Researchers are exploring interventions to address this issue. mTOR inhibitors like rapamycin. These compounds have shown potential to reduce fibrosis and restore tissue elasticity. Collagen therapies. New forms of collagen are being researched to improve tissue flexibility. Chronic inflammation. The silent fire of aging. Chronic inflammation, also known as inflammaging. It is a persistent state of low-grade inflammation that occurs with aging. Although acute inflammation is a normal response of the body to fight infections or repair tissues, when it becomes chronic, it damages tissues and organs, accelerating aging. What causes chronic inflammation? Senescent cells. These cells release inflammatory molecules that perpetuate tissue damage. Imbalance of the microbiome. As we mentioned earlier, an altered gut flora can trigger systemic inflammation. Impact on aging. Chronic inflammation is linked to diseases such as arthritis, persistent inflammation in the joints, cardiovascular diseases. Inflammation harms blood vessels, promoting plaque formation. Scientific advances to combat chronic inflammation. Science is developing new treatments to reduce inflammation associated with aging. Peptides like BPC-157 and GHK-Cu. These compounds have anti-inflammatory and regenerative properties. Immunomodulators. Therapies that adjust the immune response to reduce inflammation without completely suppressing it. How to reduce chronic inflammation. 1. Adopt an anti-inflammatory diet. Include foods rich in antioxidants and omega-3 fatty acids like salmon and walnuts. 2. Avoid inflammatory factors. Reduce the consumption of ultra-processed foods, sugar, and trans fats. 3. Maintain a healthy weight. Obesity is directly linked to chronic inflammation. In the following sections, we will explore the final conclusions on aging and how scientific advances are redefining the way we face the passage of time. Conclusion. Understanding. Aging for a healthy future. Aging is not simply the result of time passing. It is a complex biological process influenced by various factors acting at the cellular and molecular levels. The 14 markers of aging provide us with a clear map to understand how our body deteriorates over time and how we can intervene to improve our quality of life. As science advances, we are getting closer to finding ways to slow down, prevent, and even reverse some of the effects of aging, from the use of peptides and genetic therapies to the implementation of lifestyle changes. The future of longevity not only promises more years of life, but years lived with health, vitality, and fulfillment. Although we cannot stop time, we can learn to work with it. Understanding the processes behind aging empowers us to make more conscious decisions and make the most of the resources science and nature offer us. Ultimately, aging should not be seen as a loss, but as an opportunity to live with greater intention and purpose. Scientific advancements, taking care of the present. What you can do today. While scientific advances continue to develop, there are practical steps you can take today to promote healthy aging. Many of these actions are supported by scientific evidence and can have a significant impact on your quality of life. 1. Adopt a balanced diet. Eat foods rich in antioxidants like fruits, vegetables, and green tea to reduce oxidative stress. Include healthy fats like those from avocado, salmon, and nuts, which support cellular health. Limit the consumption of refined sugars and ultra-processed foods that promote inflammation. 2. Regular exercise. Exercise not only strengthens the muscles and heart, but also activates autophagy, improves insulin sensitivity, and promotes cellular regeneration. Alternate between strength, aerobic, and flexibility exercises to maintain good physical health. 3. Manage stress. Practice stress management techniques like meditation, yoga, or deep breathing to reduce cortisol levels and protect your cells. 4. Optimize your sleep. Sleeping enough, 7 to 9 hours per night, is crucial for cellular repair, hormonal balance, and overall health. 5. Stay informed. Keep learning about advancements in aging research. The more you know, the better prepared you'll be to adopt new tools and strategies. Aging is an inevitable process, but the way we experience it is largely under our control. Every decision we make today can influence our quality of life tomorrow. As science continues to illuminate the path to healthy longevity, our present actions bring us closer to a more vibrant and fulfilling future. I want to invite you to visit our health coach at tuvisalud.com if you want to learn more about aging. Our coach is ready to help you. Don't forget to share this video with your family and acquaintances. This helps us continue creating content like this. See you next time. Hugs.